In this video, we look at important exam questions for the Certified Kubernetes Administrator or CKA exam. Throughout the video, we will be solving these Kubernetes questions using the official Kubernetes documentation, which will help you understand how you can find solutions for your questions and answer them in your CKA exam. So without wasting any time, let's start with the video, but make sure to like this video and subscribe to CloudChamp. Let's go. Alright, so I'm here on my computer screen and I have all these different CKA exam questions to practice. And for this video, we are going to be using Kubernetes cluster from KillerCoda. KillerCoda is a website that provides you with playgrounds to learn different DevOps tools. For this video, we will be using the CKA playground that provides you with the environment with the current version of the CKA exam. KillerCoda provides you with a Kubernetes cluster that has 2 nodes, 1 master and 1 worker node. Questions in the real CKA exam will be based on all these different domains. Storage will have 10% of the question, troubleshooting will have 30%, and so on. If you want to get more information, click on Expand All option and you will see all the different topics that the questions will come from. In this video, we are going to be covering questions from all these different domains. So make sure you watch this video till the end and also practice it. So with that being said, now let's start with the first question. So the first question is, take a backup of the etcd cluster and save it to /opt/etcd-backup.db file. In this question, we are asked to create a backup of the etcd cluster and save it to this path. The weightage for the question is 10 points, which means this is a very important question. And if you have checked my previous videos, you might already know etcd is a storage which stores all the important information of the Kubernetes cluster. And as a Kubernetes administrator, it is very important for you to know how to take backup of etcd. So this is an important question and I'm sure this will come in your exam. So let's see how to solve this. I'm going to be using the Kubernetes documentation to solve this because you will be able to use this documentation even when you give your CKA exam. So let's search for etcd here in the search box. And I'm going to open the first link here which says operating etcd cluster for Kubernetes. In this, if you see on the right side here, there are different topics here. Let's go and click on the backing up an etcd cluster option here. You can go ahead and read about it if you want to, but the exact command to take the backup is this one. So I will copy this command and paste it in my terminal. If you look at this command requires you to add few things. The first is the endpoint on which etcd is running. So it's already here. The endpoint is 127.0.0.12379, which is where the etcd is running. Along with this, you also need the CA cert, which is the trusted CA file. You need the certificate, which is the cert file, the key, which is the key file, and also the place where you want to store your backup. So where can I find all this data? This data can be found in the manifest file, which is required to run the etcd pod. So if I do kget pods -a, I will see all the pods from all the namespaces. And you can see etcd is running in the kube system namespace, and the name of the pod is etcd-control plane, which means this is a static pod running on control plane node. And we all know this manifest files for all static pods are present at the folder which is etc/kubernetes/manifest. This is where you can find all the manifest files for all the static pods. So here is the etcd.yaml file. And if you want to see the information for CA cert, for cert file, for the key file, let's do cat here. And I'm going to say cat etcd.yaml. If you go here, inside the command section, you will see this is a cert file. And this is the trusted CA file that we require. Along with that, we also require the key file, which is present here. So this is all the data we require to take the backup of our etcd as per this command. So let's put that data here. So instead of getting all this information here, I'm going to run a grep command. So I'll say cat etcd.yaml grep file. Once I do that, I'll get all the information required here. So let's put this data one by one in our command. So this is the command, which is etcd-ctl_API equals to 3. etcd-ctl endpoint is this. We need to fill all this data now. So the backup location where we want to store our backup is going to be /opt/etcd-backup.db. So I'm going to put that here, /opt/etcd-backup.db. Make sure you always copy paste stuff rather than writing it yourself in the exam to avoid issues. But I don't have the option to copy paste from PPT, so I'll type it out. Along with this, you need to put the key file. The key file is present here, which is this. I'm going to copy this and paste it using Ctrl-Shift-V. Along with key, I also need to put the certificate file.
So the certificate file is here. Let's copy this and paste it here. Lastly, we also need to put the CA cert file, which is actually the tested CA file that is here. So I'm going to copy that and paste it here. Once I run this command, I should be able to get the backup stored in this particular path. So let's press enter and you get an output saying snapshot saved at this path. To confirm, I'm going to just run the cat command for this folder and you will see all the data is now stored for HCD in this particular file. So this is how you can solve this question and get 10 points for your exam. Let's go to question number 2. The next question is create a new deployment called nginx-deployment with the image nginx:1.16 and 2 replicas. Next, upgrade the deployment to version 1.17 using rolling updates and record it. So in this question, we are asked to create a deployment with this name and using the image this one and having 2 replicas. Once the deployment is created, we need to upgrade it to version 1.17 using rolling update strategy and also record it. So let's see how we can solve this. If you have watched my previous video, especially the important Kubernetes commands video, you will know how you can use imperative command to create objects like deployment, pods, and a lot more. So for this question, we are going to be using imperative command. And if you don't know about that, make sure you check the previous video. So let's create a new deployment with this name and having this image with 2 replicas. Using imperative command, you can just do kubectl create deployment. The name of the deployment is going to be nginx-deployment. So let's put that name here, nginx-deployment. Image used for this deployment is going to be nginx:1.16. So I'll say --image is going to be nginx:1.16. Replicas has to be 2. So I'll say --replica and it is to be 2. So once I press enter, deployment will be created. And you can also confirm by running get deployments. You will see an nginx deployment is now created having 2 replicas, which is now going to be creating, and you can see it's running as well. Alright, so once the deployment is created, we are asked to upgrade the version from 1.16 to 1.17 using rolling update. In Kubernetes, there are 2 ways to update deployment. One is by using the strategy which is recreate deployment, that will kill the pods and then recreate it. The second one is rolling update, which is the default one, and we are asked to update our deployment using this rolling update. As rolling update is the default deployment, you don't have to change anything. Instead, you just need to change the image from 1.16 to 1.17, which you can do either using the kedit command, which is going to edit the manifest file. So if I do kedit deployment nginx-deployment, I can go here and just change the value from 1.16 to 1.17, which is one way to do it. The other way is to using the imperative command. So let me show you that. So using the imperative command, which is the kSetImage command, I will be able to change the image from 1.16 to 1.17. You can run this command with the help attribute. So you can see how you can actually use this command. So kSetImage deployment and then use the pod name equals to the new version that you want to update. For me to run this command, I need to know what is the name of my container. I can do that by running get deployment -o YAML, and you can see the name of the container is nginx. kubectl set image deployment. Name of the deployment is nginx-deployment. Name of the container is nginx, and I want to have the new version which is going to be nginx:1.17. So I'll say nginx:1.17. This is the command to upgrade image, which is using kubectl set image. Now, if I want to record this, I'll say --record option, and if I press enter, you will see the deployment for nginx has been updated. To confirm, I want to say get deployments and nginx deployment -o YAML. You can see now the image is 1.17, and it has also been recorded. To confirm that, I'm going to run the command rollout history for deployment, which is nginx deployment here, and we can see it has been recorded, which is true. So this is how you can update images for deployment and get 15 points for this particular question. Now let's move on to the next question. So the next question is create a static pod named static-pod on the node 01 node that uses the busybox image and the command sleep 2000. So in this question, we are asked to create a static pod with this name on this particular node that uses busybox image along with the command sleep 2000. As we have already discussed in the first question, the static pod are something that has manifest stored in the etc/kubernetes/manifest files, and they are usually run on any of the nodes. In this question, we are asked to specifically run this pod on node 01 and use this image. So let's see how we can solve this. In the cluster, I'm going to run kget nodes to show you all the nodes I have right now. And there are two nodes, the control plane node and the node 01. Right now, I am on the control plane. If I want to run a pod in the node 01, I need to have the manifest file stored in the /etc/kubernetes/manifest folder inside node 01. So let's create a pod manifest and then store it inside this. So to create a pod manifest using imperative command, we already know we use the kubectl run option. If you don't know this, make sure to please check out the important Kubernetes commands video that I've created. So I'll say krun, the name of the pod, which is static-pod. So static-pod. The image you want to use is going to be busybox image. So I'll say --image is going to be busybox. And we don't want to actually create this in the control plane. So I'm going to say try run equals to client. And I want this as a manifest. So I'll also run -o YAML. Correct? Along with this, if you see, it also wants you to have a command which is sleep 2000. So to add a command, you need to say --command. And then I want to say sleep 2000. So I'm going to press enter now and see the output. So this is the output that provides us with the manifest files. The manifest file has the name of the pod as static pod, which is check. Next thing is to use the busybox image, which is also check. The image is busybox. Also, you'll need to add a command which uses sleep 2000. And you can see in the command section, we have sleep 2000. So to run this as a static pod, we need to put this in the /etc/kubernetes/manifest folder. So now we want to run this on node 01 node. So to run this, we have to first go inside the node 01, which is done by SSH, and the name of the node, which is node 01. So I'll say node 01. And you can see now I'm inside node 01. Let's go to /etc Kubernetes manifest folder. If I do ls here, you can see there are no manifest right now. I'm going to simply copy this manifest and create a file named as static.yaml. So let's say nano static.yaml, paste my manifest file, Control S, Control X. And now if I do exit from the node 1, going back to control plane, running kget pods, you should be able to see a pod created because we have the manifest stored in this particular path. Once I press enter, and you can see there's a pod named as static pod -node 01, which is created 14 seconds ago, and this is running on node 01. Confirm, I'm going to say kget pods -o wide, and now you can see this pod is actually running on node 01. Now let's move to the next question, which is question 4. It says create a new pod called superpod with the image busybox:1.28 and allow the pod to be able to set sys time. The container should be sleeping for 4800 seconds. So in this question, we are asked to create a pod with this name, the image should be this, and the pod should be able to set sys time, and the container should be sleeping for 4800 seconds. So I know how to create a pod with this name and the image, but I don't know what sys time is, which we are going to check later on from the Kubernetes official documentation. So for now, let's go ahead and create a pod with all the other options, and then we can add systime capability later on. So I'll go and run the command kubectl run. The name of the pod is superpod. The image that I want to use is going to be busybox image. So busybox:1.28, which is this one. And then I also want to have the container running or sleeping for 4800 seconds. So I'll add a command --command, and the command is going to be sleep 4800. Alright, now I can go ahead and press enter to create a pod with this, but I want to also set the sys time. So instead of creating, I will just store the manifest in a file and then add it later on as well. So to do that, I'm going to add the dry run option here. So I'll say dry -run equals to client, and I want to get the output as YAML manifest. So I'll say -o YAML. Once I press enter, you can see this is the manifest file. Let's store this in a file named as q4.yaml. Alright, if I do q4.yaml, you will be able to see this. Now our manifest is ready. The only thing we need to add is the systime capability. And to do that, I'm going to go here in the documentation. Let's search for sys_time. Once you search for it, this is the first link that you need to click on because it has systime inside it. So the link says configure a security context for a pod or container. Now I'm going to scroll down, or you can simply click on this, but let's scroll down where you see the capability option. So if you scroll down, this is where you need to look at. In this, you can see the sys capability is added, and that is done using security context, which is inside the containers, inside spec section. So I'm going to copy this. And let's go in our file. So I'll say nano q4.yaml, and I need to put this inside container, which is inside spec. So I'll go here, make sure to use the correct indentation or else you will face an error. So I'm going to paste this here, and I will remove netadmin because I don't want that according to the question. Let's save this. Now once you have it ready, and let me show you the manifest one more time. You can see the manifest is using the name superpod. It is sleeping for 4800. The image is busybox 1.28, and it also has ability to set systime, which is added by security context here. Once you have this ready, all you need to do is to run the kubectl create command. So I'll say kubectl create -f and the name of the file, which is q4.yaml here. Once I press enter, I should be able to get a pod, which is now created. You can see get pods -w, and a pod is running 5 seconds ago. Now, if you want to check if everything is fine, you can simply run the get pods superpod -o YAML, and you will see this is the exact manifest that we have used. So the manifest also has the systime capability added. The image is busybox 1.28. It is sleeping for 4800, and the name of the pod is superpod. So this is how you can solve this question and get 8 points. Now let's move on to the next question, or the last question of this video. I hope you are enjoying this video. So please make sure to like this video and comment down if you want more of these. Let's move to the next question now. The next question is, create an Nginx pod called Nginx-resolver using the image Nginx. Expose it internally with a service called as Nginx resolver service. Test that you are able to look up the service and the pod names from within the cluster. Use the image busybox for DNS lookup. Record results in Nginx SVC and Nginx pod. So this is a very confusing question, but let me try to explain you this. So first they're asking you to create a pod with this name using the image Nginx. Once the pod is created, they want you to expose it using a service which is called as Nginx resolver service. And they're asking you to expose it internally, which means it is a cluster IP service. And then once it is exposed, you need to test it. So test that you are able to look up the service and the pod names from within the cluster. And you can do that by creating a pod with the image busybox and running the DNS lookup command. So once it is done, you need to then save the results in the Nginx-svc file for service and Nginx-pod file for pod. So this is a networking or a DNS kind of question. So let's try to answer this. The question has weightage of around 12, which means this is very, very important and you should know this. This is actually very easy, so let me show you how you can do this. First, let's create a pod named as the Nginx resolver with this name, and we can do that by running krun Nginx-resolver --image, and the image you want to use is Nginx. So I'll say Nginx. Once I press enter, a pod is now created. I can confirm by running get pods, and we have a pod which is now creating state. I can do -w, and you will see a pod will be soon created. So it's now running in, and let's go create a service to expose the pod with this name. So I'll say expose. I want to expose a pod with the name as Nginx resolver, and then I want to expose it with the service named as this. So I'll say --name. Name of the service is Nginx-resolver-service. So Nginx-resolver-service. So I can do that and press enter. Once I press enter, it will give me an error saying it also requires a port. So we need to add a port. The port for Nginx is going to be port 80. So I'll add that, and now the port service has been created, which is also exposing our pod. You can confirm by running get svc, and you can see an Nginx resolver service has been created, which is of type cluster IP, and it's running on port 80, created 6 seconds ago. So now we have the first part done, which is creating Nginx pod and the Nginx service. We now need to test that we are able to look up the service and the pod from within the cluster. And to test that, we need to create another pod. So I would create a pod with this image busybox 1.28. Let's name this as anything. So I'll say test DNS. And the image I want to use is going to be busybox 1.28. So busybox 1.28. Now, if you want this to run without any errors, you also need to make sure that the container is running all the time. So we need to add a command for sleep, or else this container will go in the crash loop back. So I'll add command sleep, let's say 5000. Once I do that, now we have a pod named as test.dns created, and I can confirm by saying kget pods. It's also running 5 seconds ago. So let's try to test this part, which is able to look up the service of the pod. And if it is able to do that, we are going to then store the data in these files, nginx.svc and nginx.pod. To check that, we need to run the nslookup command, and we can run the command inside this test.dns. If you have followed my important kubectl commands video, you know to run a command inside a pod, we need to use the command kexec. So I'll say kexec -it. The pod name is going to be test.dns. And I want to run a command which is going to be nslookup and the name of the service. So I'll say nslookup and the service name, which is nginx resolver service. So let's paste that and press enter. Once you press enter, we are able to get the output here. So you can see we are able to look up from inside the cluster. So we can use this. But remember, a service can be called with the name or with the name dot namespace or with the name dot namespace dot service dot cluster dot local. So you can either save this data inside the nginx.svc, or you can run the same command with using the proper name for the service, which is here. Now, if you want to get the data of all the names, you can search for DNS here, and you will see DNS for services and pods. If you go down, you will see how there are different ways to call a service or to name a service. A service can be service.mynamespace.service.cluster.domain or just service name, running the same command using the pod IP. So let's get the pod IP first. I'll say kget quads -o wide, and this is the pod nginx resolver. This is the IP address. I'm going to copy this, run the same kexec command, this time with the IP address of the pod, and press enter. So you will get the complete name according to what you see in this documentation. So we are able to look up the service as well as pod internally from the clusters, and we need to save this data inside the file. So let's run the same command and now save this data inside nginx.pod for the pod. So I'll say nginx.pod, and similarly I'll do the same for service as well, and I save this data inside nginx.svc. So if I do ls now, you will have two files which has the data that confirms that you are able to look up the service and the pods from within the cluster and store it in nginx.svc. So this is the end of our video. I hope you enjoyed this video, and now you are able to understand how to answer all these different important CKA questions. I have more of these, and if you want me to create a video or a part 2 of this series, let me know in the comment section. I hope this video was informative. Please like this video, subscribe to CloudChamp, and have a good day. Bye.